In this lesson, we're going to learn how to formalize the process for solving linear equations algebraically. Remember, linear equations means that there's just a single variable with a power of 1 involved. Remember that we looked at solving equations in 3.1. We looked at an algebraic approach, we looked at a graphical approach, and a numerical approach. So this one, we're focusing mostly on the algebraic. So I'm going to use an example to show you what I'm looking for, and then lay out some guidelines to follow. So here's a simple example. We're going to solve 7 times x minus 3 equals 2 times x minus 9 plus 2x. And I'm going to lay out some guidelines for you to follow. So when I look at a problem like this, I want to go in a very systematic way to make sure I do everything properly, taking my time and make sure I don't do rush or anything like that. So the first thing you want to do is you're going to use the distributive property to eliminate your grouping symbols, the parentheses. So remember, the distributive property basically says a times b plus c, and you distribute them like so, and you get a times b plus a times c. So the multiplication distributes across addition or subtraction. So that's what we're going to do first. We're going to multiply this to everything in that parenthesis. And remember, it's just the number right in front of a parenthesis. If there's a sign in between, like a plus or minus, then it's not a distributive property. I get 7x minus 21 equals, here's another one. So we're going to distribute that one, 2x minus 18. And this is just a standalone term, so I put a plus 2x back in there. So that is our first step. Here's a step that is not illustrated in this example, but I'm going to write it in here now for future reference. What if the fractions are involved? To eliminate fractions. To eliminate your fractions, you're going to multiply both sides of the equation. Abbreviate equations by the least common denominator. You want to do this, just starting out, you want to do that after you've gotten rid of all the parentheses. At this stage in the game, you can look and see if there's any fractions, and you can eliminate it by doing this process. I'll illustrate this one in a later problem. So we don't have fractions, so we go right to the next step, step 3. And on each side of the equation, so on each side, so we got this side over here and this side over here, we want to combine like terms. What are like terms? Like terms are variable terms that have the same exact variable, or constant terms. So in this case, I only have one set. These two are like terms on this side. Nothing's like over here, so we just rewrite the whole thing. These are like, so we want to combine them. I have 2 x's plus 2 more x's gives me 4 total x's. And the minus 18 just comes on down. Now what? If there is a variable on both sides, then add the opposite of the smallest to both sides. Why do we keep doing anything to both sides? It's because it needs to keep this equation balanced. This equal signs means that it is in balance. If I only do one side, then I'm just going to be unbalanced, and that will mess everything up. Now, here I say to add the opposite of the smallest to both sides. Could I add the largest to both sides? And the answer is yes. But by doing so, you're bringing in an extra step later on. If you get in the habit of moving the smallest one, you then will avoid that extra step later, for the most part. So the smallest one here is 4x. So the opposite of positive 4x is negative 4x. I'm going to add a negative 4x to both sides. You can also say you're going to subtract 4x, but I like to do it adding the opposite. It allows me to be more consistent. Combine in column format. So 7x plus a negative 4x is positive 3x. Minus 21 just comes straight down. The equation equal sign comes straight down. This right here is 0. And then I have a minus 18, which comes down. This is where we are now. In this situation, I have a variable term, a constant term, equal to a constant over here. We're trying to get to x equals, so I need to undo these things that are going on. So the next step is to add the opposite of the constant to both sides. So that we isolate the variable term. So I want this by itself. So the opposite of a negative 21 is a positive 21. So add 21 to both sides. 3x, that goes to 0, equals, and this over here is 3. As you can see, we're getting close to the end. Now we're going to, now a lot of times people will teach us to divide by 3, and that's fine. The only problem with that one is if you divide, go by that process, then there's some problems that require you to do 2 steps here, whereas I'll talk about it in 1 step. If you look at the problem this way, we can simply multiply both sides by the reciprocal of the coefficient of the variable term. So what does reciprocal mean again? Reciprocal means to flip over. The coefficient is the number that is right in front of the x. So if you basically erase the x, whatever you see is the coefficient. So the coefficient here is 3. Its reciprocal is 1/3. So I'm going to multiply both sides by 1/3. 1/3 times 3 is just 1. So I get x equals, and the side over here is the same thing happened. So x equals 1. And in all things, the last step you do is check. Just because you got an answer doesn't mean it's right. You need to check that answer when you plug it back in here, and it should be true all the way across. So real quickly, this will be a 7. If I put a 1 in here, it's going to give me -2. So that's going to be a 7 times -2. This will be a 2 times. If I plug a 1 in there, it gives me -8. And then 2 times that will give me a 2. -14, -16 plus 2. And yes, that's going to check out, which means that is my solution. So this is the process you want to follow for solving linear equations. Now, sometimes they'll be less complicated than this. Sometimes they might be more. I don't know. But if you follow this process, it should handle all linear equation processes. Here, let's solve another one. It's 4x, and it's 6 minus 1/2, 5x plus 1. So following this process, if I have parentheses, I want to eliminate them using the distributive property. So take your time, draw these little lines to help you organize your thought process for each one. -5 times 3, -15. -5 times a -x is a positive 5x plus 4x equals 6. This is a -1/2, and you're going to distribute that to everything inside. The 6 is already out in front. That one is not associated with this distributive. A negative 1/2 times 5 is a negative 5 divided by 2. And a negative 1/2 times 1 is a negative 1/2. So here we have fractions we want to eliminate. You have a kind of a choice here. I mean, I have fractions, and I can combine like terms, but then I got to add and subtract fractions. This is why I like to do the fraction elimination in the second step. Okay? And so to eliminate the fractions, we got to multiply both sides of the equation by the LCD. So to do this, I recommend that you put both sides of your equations in parentheses. And then in the front over here, what is the LCD, which in this case would be a 2. You're going to multiply everything in here by 2, and you're going to multiply everything in here by 2. So this gives me negative 30 plus nx plus 8x 12. And the reason why we multiply by the LCD is because 2 times this, the 2's just reduce out and left with just 5x. And then half of 2 is 1. See, no more fractions. Combine like terms on each side. I have like variable terms, and you can leave it in the same order. You can rewrite it. I usually like to put the x terms first. Minus 30 minus 5x plus 11. The smallest term, they both have a variable on both sides. The smallest one is this. The opposite of negative 5x is positive 5x. This then is going to be 23 minus 30. That's gone. That's 0, and that's 11. Add the opposite of the constant. The opposite of negative 30 is positive 30. 23x equals 41. And then the reciprocal of 23 is 1 over 23, 1 over 23. And so x equals 41 over 23. And you can plug that in with a calculator to check your answer, but it will work. So those 2 examples using the techniques that we have over there. Here are some side notes that I want you to see. I'm going to do another problem to show you one of them, and then I'll talk about what's going on. So here's this example. 6x minus 8 equals 2 times 3x minus 4. So I see parentheses, so the first step is to distribute, and I'll get 6x minus 8 equals 6x minus 8. And you'll notice, you start noticing something very interesting here. So opposite of this is negative 6x, and then we get negative 8 equals negative 8. The letter disappeared. The variable term is gone. Okay, so this is a special situation. When the letter disappears, 2 things can happen. This one, where the 2 numbers are equal, and another one where the 2 letters are not. When the 2 numbers are equal here, this is a true statement. So if you get a true statement, as in this case, then that means that the 2 that you have infinite solutions. That means all answers work. Infinite solutions. Why? If you think back to how we did 3.1, where we looked at this as graph this side as a line, graph this side as a line, and see where they intersect, these are literally the same line. So that means they intersect at every single point. That's why there's an infinite number of solutions. What happens if I do a problem, and I'll just make one up very quickly here. What if I get 2x plus 1 equals 2x minus 3? In this case, when you add the opposites there, you get 1 equals negative 3. Well, this is a false statement. The letters have gone, the variable term has disappeared. This is a false statement. So what does this mean? Well, this means that you have no solution. That would be your answer for a false statement like that. No solution. Why? Because if I graph both of these things as a single line in a graph in a coordinate system, then they will become parallel. You have no solution because they never intersect because they are parallel. So that's what happened on this one, and that's what happens when you solve these things out. Now, there's one more little technique that might be of benefit to you. This is just a little side note for fractions, because you can't guarantee any kind of look. We don't know what equations are going to look like when we try to solve them. But here's a technique that a lot of times people forget. If I have a fraction, then I can split this fraction up. If I have a sum or a difference on top and a single number on the bottom, it literally means this plus b over c. I can split it up into two different fractions like that. Why would that be beneficial? What if you have an equation that looked like this? If I have an equation that looks like this, there's a couple things I can do. One of which is I can split this into two different fractions, into x over 2 plus 2 over 2 equals 5. And then this is just simply a 1. And we'll just go ahead and finish this one. Plus 1 equals 5. So that brings me to another note. What does this mean? What does x over 2 mean? It means 1/2 times x. So get used to seeing this and making this connection, because this is an important connection that will help you in solving many equations in the future. So move the 1's over. I get x over 2 equals 4. The reciprocal of this, because now I see this as a 1/2, the reciprocal of this is a 2. So I'm going to multiply both sides by 2, and I get x equals 8. And never forget what you're doing here. What number divided by 2 is 4? What number divided by 2 is 4? Well, you can see the answer is going to be 8. So just be careful on how you go about doing this problem. And so we'll do more examples together. These are some simple things that will help you in solving your equations.